Good morning.
Morning.
Wow, this is starting to look like a BC class.
Because of how small it is.
Yes.
BC's had more people in it going to the Zoom meetings.
Ooh.
The amount of people joining Zoom meetings in AB has considerably gone down. C. Okay. Yeah, like Sydney did, if you have any questions from the FRQs, just you can put them in the chat and that's what today's for, answering those. Okay. Okay, well, it's 11:05. Start. Before going over some of the questions, just some of the same reminders as usual, along with some new ones. So let's go. This is the same page I've shown many times. Your exam is next Tuesday at 1 p.m. apcoronavirusupdates.collegeboard.org, where you have tons of information that's about the exam. You know that info by now. Yesterday, I posted a bunch of links. These are those links again, but you can see them in the AP class, in Google Classroom. You really need to go through some of these. You really need to be prepared for the for just the process of doing the AP exam and to know how you are going to submit your answers and all of that. So because of that, if you go to one of the, I think I mentioned it Friday as well, but I didn't want to do that. Here we go, a highlighter. This one right here, the demo site. You need to practice the demo ahead of time. You need to practice the demo ahead of time so that you know how long it takes to submit and exactly how you are going to submit your answers. So you need to practice the demo ahead of time. So cb.org/AP demo. If we go there, that takes you to this website. If you haven't already watched this video, I think I posted it, but it's also in those links as well. It guides you through like how the AP exam process will work and how you will submit your answers. And you can actually do the interactive practice of doing the demo. You would then click interactive demo. You type in practice and you can practice the process of submitting your answers exactly as you would on the day of the exam. What else? It doesn't work on every browser. Don't use Internet Explorer. You should really never use Internet Explorer. During the exam, do not refresh your page or press the back button. That also won't work during the demo either. It pretty much takes you out of the exam, which that would be bad. So again, practice on the device you're going to use, practice on the browser you're going to use. Make sure you know how it's going to work ahead of time. The demo doesn't use an actual exam question. The time is just running so that you get the feel of like the time running and what the system looks like. A few things about submitting your answers. You can either submit a text file, meaning like a Word document or a Google Doc, where it's in the form of .txt or .doc or .docx. You can attach photos or you can copy and paste. The highly recommended one is attach photos. Most of you have already been doing that for your Google Classroom assignments. So, under attaching photos. Requirements, each photo response can't be more than one page. If your response is more than one page, you can submit up to 5 photos. So you would just take a picture of your whole page, then you take a picture of your next whole page, and so on. You can have up to 5 photos per page. There's 2 per question, and there's 2 questions on the AP exam this year. So that's 10 pieces of paper. You need to have your AP ID, which you will have by then, your initials, and the page number at the top of each page. Have that ready ahead of time. Have that ready ahead of time. Since you can have up to 5 pages, 5 pictures per question, have 10 sheets of paper out ahead of time already with your initials, page number, and AP ID on each of those. It'll only allow you to attach one photo at a time, but then you can just click and attach you can do it again and attach the other photos. Your photo format would need to be .png, .jpeg, or .jpeg, or .jpeg. Yeah, that's how your photos need to be. Some of you, for your Google Classroom assignments, have been, like, I guess, using an iPad or using a touchscreen computer, been essentially handwriting on a PDF and saving it as a PDF. Or you've taken or used a scanner to take pictures of your handwritten work and saved it as a PDF. That is okay, but if you have a PDF, the PDF you would submit under the text file option. PDFs are submitted under the text file option, and you can only submit one PDF for the whole thing. So you can only submit one PDF for the whole thing. So if you do have your pictures changed into a PDF, it can only be one PDF. So like all the pictures in one file. But I would just recommend taking a picture per page, having them saved as JPEGs, and that would be the easiest way to do that if you are handwriting it. Or if you really want to do the like writing on an iPad or touchscreen computer or something, then you can save it as a PDF, but that's under the text file option when you submit. But if you have other questions about how that would work, at least practice it the way you do it ahead of time. Another way to figure out some of those answers to those questions, the same YouTube channel I continue to recommend, the AP Live videos with Mark Corrali and Verge Cornelius. Verge is the one who made all of our circuits we ever did. This week, they did a mock exam on Monday. Then they went over that mock exam yesterday. They're doing another mock exam today, going over it on Thursday. And when they're doing the mock exam, they're doing it the way it will work in the system and having people submit a response and practicing with the timing. And they're also going over like how the system would work and like which different ways you can submit stuff. So if you haven't watched any of these videos yet, this week would be a great time to do that. Well, that's all of that. Let's answer some of your questions about the FRQs. Okay, FRQ 3C. 3C, we'll go over that one first since that's the only one asked about so far. Okay. Right here. So 3C. I did notice that in the key, it was, I'm going to completely move that out of the way. There we go. In the key, they had this written a little differently, but all they really did was they distributed and then pulled something out separately, and it'll make more sense how they got that when we do the problem. So in problem 3, again, for this week, you are only supposed to do FRQ, Super FRQ number 3, and Super FRQ number 5. If you do the others, that'd be a great idea at some point, but you only have to do 3 and 5. Okay, so on 3C, well, 3 in general, they told us that the derivative is xy cubed, and that the second derivative is y cubed times this parentheses 1 plus 3x squared y squared. And part C asks us to verify that the second derivative really is that. So to and then determine whether there's a point of inflection at 1, 2. Well, to verify that the second derivative really is that, let's take the derivative of the first derivative. So we are going to take the derivative of the first derivative. That's what we're going to do. Take the derivative of the first derivative of x, y cubed. Okay, well, multiple things are going to happen here. This is implicit differentiation. We have one function x and we have another function y cubed that are being multiplied together. So we have to use product rule. We'll have to use product rule. And then also, since y is a function, when we take the derivative of y, chain rule will be involved, and we'll have to take also multiply by the derivative of y, which is dy dx. So taking the derivative of this, first product rule. Derivative of the first means derivative of x, which is 1 times y cubed as is. So we get y cubed, then plus. The first function as is times the derivative of the second, which is 3y squared. Then chain rules involved, we now have to multiply by the derivative of y, which is dy dx. And that right there, that's how the key wrote part of the answer, part of the question really. But we can go one step, we need to go one step further to really show what they're asking. Well, you need to go one step further anyway, no matter what. We're going to replace dy dx with what dy dx is. This is y cubed plus 3x squared times dy dx is xy cubed. So that is our second derivative, one form of it. But that's not what they had up at the top or what they asked us to verify. But what they did was they just factored out.
Mr. Hunter,
Yeah, I miswrote that. Yeah.
Okay.
You were saying that at the same time I noticed it. I was about to factor and then realized that I didn't have what I needed to factor. So it should be 3x y squared, then in parentheses, the xy cubed. There we go. Okay, so we want to factor something out so that it looks like what they're telling us to verify. So if we do that, we want to look at that, so we're going to factor out y cubed. When we factor out y cubed, we're going to have 1 plus, well, so the y cubed is right here, so that's just going out. We're left with that x right there. We'll go ahead and multiply it by that x squared, giving us 3x cubed y squared. And there we go. We have now verified and used both product rule and chain rule that this really is the second derivative of the first derivative. We're also asked to show that the original function, well, we're asked if the original function has a point of inflection at 1, 2. Well, a point of inflection is where the second derivative equals 0 and changes from positive to negative or negative to positive, because a point of inflection is where there's a change in concavity. So the only way 1, 2 could be a point of inflection is if the second derivative is 0 there. So let's plug 1, 2 in and see if we get 0. Well, that would be 2 cubed times 1 plus 3 times 1 cubed times 2 cubed squared. Is that going to give 0? No, because that's 3 times 4. That's 12 plus 1. That's 8 times 13, which is not 0. So no point of inflection at 1, 2, since the second derivative does not equal 0. Okay. Any other questions from those Super FRQs? You could turn your mic off to ask, or you could just put it in the chat. But that's what today's about, just answering the questions you have from any of the assignments or about how the AP exam will work. Which one?
F of number 3.
F number 3? Oh, and then Casey also has
Yeah.
E number 3. Okay, F and E.
The one about under and overestimates.
Okay. Okay, 1 second. Okay. So E and F on number 3. Well, E, we're asked about the equation of tangent line of F at x equals 1, and then to use that tangent line approximation to find the value of, to approximate the value of F of 1.5. Well, do we know what F of 1 is? Because we'll need that.
2.
Yeah, they told us. F of 1 is 2. Okay, so we need to also now figure out what F prime of 1 is. Prime of 1. Okay, well, they gave us the derivative, so we're just going to plug that in there. So that'd be 1 times 2 cubed, which is 8. Okay, now let's make our equation. So we're gonna have F of 1 over on the right side, like I usually been doing. Then we have 2 plus 8 times x minus 1. Okay, so there's the tangent line. And now we'll do the approximation. So then y equals 2 plus 8 times, we're approximating 1.5. 1.5 minus 1. Okay, 1.5 minus 1 is 0.5. 0.5 times 8 is 4 plus 2, 6. So 6 is approximately F of 1.5. Okay, ideally, we all remembered how to do that, but on F, we're asked, is that approximation either an underestimate or an overestimate? An underestimate or an overestimate. And to remind us how to figure that out, I'm gonna draw a quick picture. So
Mr. I have a quick.
We have something that's concave up, and we have a tangent line along something that's concave up. That entire tangent line is below the graph, is below the curve. And this is a tangent line approximation, so that red tangent line is underneath the curve when it's concave up. So when it is concave up, that would be an underestimate. Well, if we have something that's concave down, that tangent line, the entire tangent line is above the curve. It's over the curve. It would be an overestimate. So concave down is a overestimate. And so we want to figure out if this would be an underestimate or overestimate. So we need to figure out what the second derivative at 1 is, whether it's concave up or concave down. So F double prime of 1. Okay, well, they gave us the second derivative. We also found it in the previous problem. So that will be 2 cubed times 1 plus 3 times 1 squared 2 squared. And I don't really even need to actually evaluate that. Is this thing positive or negative?
Positive.
It is positive. And since it is positive, that means we are concave up. So the approximation is an underestimate. Okay. Now, what was the next question someone asked about?
Oh, that was me. I was asking, so whenever we evaluated f of 1, you chose 1 because it was close to 1.5, which is what we were trying to approximate. But why not pick 2? Like, why did you round down to 1?
Oh, I mean, 2 may have worked as well. The main reason I chose 1 was because they specifically said, write the equation of the tangent line of the function at x equals 1. So they said x equals 1.
Oh, okay, got it. Okay.
So that's the main reason why I chose 1 here. As well as we also don't know what f of 2 is. This problem gave us the first derivative, gave us the second derivative, and then they only gave us 1 point of the original function. The only point we know about the original function is f of 1 equaling 2. So we couldn't have used f of 2 anyways, because we don't know what that is. Okay, Samra, you asked about 4K. Let me go look at that. Oh, 4N. 4N. Okay. So let me look at 4 real quick. 4N. Okay. Okay, so on 4N, here's the picture from 4, which we're told is a graph of f prime. And in part N, we're told let p of x be f of x squared minus 1. We're asked to find the slope of the line tangent to the graph of p at the point where x equals 2. Okay. Well, let's take the derivative of p then, because slope of a line tangent is the derivative at the point. Slope of the line tangent to a function is is the derivative at that point. It's also the instantaneous rate of change at that point. So P prime. So, well, we're going to have to chain rule here, take the derivative of the outside f prime of the inside left alone, x squared minus 1, and times the derivative of the inside. Well, derivative of the inside is 2x. Okay. Well, now let's just plug in 2. So we need p prime of 2 is just essentially what they're asking for. So f prime of 2 squared minus 1 times 2 times 2. 2 squared minus 1, that's 3. So f prime of 3 times 2 times 2 is 4. Okay, and then f prime of 3. Well, this is the graph of f prime. So f prime of 3 is just whatever the y value is on this graph when x is 3. 1, 2, 3. Okay. So right there. So 2 times 4, which is 8. Yeah. Okay. Any other questions you want me to go over from any of these super FRQs or about the ABV? Oh, we have 15 people now.
Can we do E on number 1?
E on number 1. Okay. E on number 1. Well, number 1 in general, let's just talk about what's happening in the problem. We have coal burning in a furnace, exhausting the resource. The rate at which coal is burning, measured in pounds per hour, is this B of T function. We're told at time 2 hours, a worker starts supplying more coal into the furnace. The rate at which coal is being added, measured in pounds per hour, is given by S of T. The worker stops adding coal at time 5. At time 0, there was 500 pounds of coal in the furnace. Okay. Well, let's do this. This b of t function is the rate at which it's leaving. That's the rate at which the coal is leaving the furnace. It's being burned. And S of t is the rate at which it's entering the furnace. So that would mean S of t minus b of t this tells you the rate, so the rate at which it's entering minus the rate at which it's leaving just tells you the rate of the amount of coal that there just is in the furnace. And if we integrate a rate, that tells you the amount. If you integrate a rate, that would tell you the amount. We're asked to find the minimum or maximum amount of coal in pounds from time 0 to time 5. And the times when they occur. Okay, well, a minimum or a maximum between this time interval, thinking absolute maximum, minimum, it'll either occur at the endpoints or it'll occur at the critical values, at the min or max. And the min or max of the amount will be when the critical value, when we have a critical value, so when its derivative is 0, which we just take off that integral back to what I said earlier, S of t minus b of t, the entering rate minus the exiting rate, that would tell you the rate of the coal. So when that is 0. Actually, no, we need to be a little more specific. For time, it's more like a piecewise function, like in D. D asks, so we'll answer D real quick, or at least part of it. We're asked to write a piecewise function, A of t, that gives a total amount of coal in the furnace at any time between 0 and 5. Well, from 0 to 2, from 0 to 2, the only rate we know about is B of t, the coal leaving. And we want a equation for the amount of, just the amount of coal, not the rate, but the amount. Well, if we have a rate and we want an amount, we need to integrate and then just add the 500 from the beginning. So A of t for t less than or equal to 2, it will be 500 plus the integral from 0 to 2 of b of t. That right there would represent the amount of coal between 0 seconds and 2 seconds. And then once we start adding coal to the furnace, which is S of t, then we'd still have that 500 really. No, it wouldn't be 500 anymore. It would be A of 2, because now we're starting at time 2. a of 2 plus the integral from 2 to, actually, it should say x. I should say x of the entering minus the exiting, so s of t minus b of t. That's for t greater than or equal to 2. Honestly, I don't see a problem like this likely this year, but to continue, we want to know a min or a max amount of coal. So then you would take the derivative of this amount and you would need to check all the different special points at the beginning, at 2 and at 5. The derivative of this first section is just b of t.
So we just plug in the endpoints, right?
You'd plug in endpoints 0 and 5. You'd need to figure out what a of 2 is, which just is 500 plus the integral from 0 to 2 of b of t. And then between 0 and 2, so if we want a prime of t, well, take the derivative of 500, that's 0. If we take the derivative of this integral, that's just b of x, or b of t, like however you want to write that, when t is less than or equal to 2. And when we take the derivative of this piece, well, that's just numbers, that's 0. Integral of this is just going to be the s of t minus b of t for t greater than 2. So, and you want to know when this derivative equals 0. So when t is less than 2, if b of x is ever 0, then that's an important point. And for t greater than 2, if s of t equals b of t, then that's a critical value.
Oh, okay, I get it. Thank you.
Any other questions from any of the Super FRQs? I specifically assigned numbers 3 and 5 because they covered so many different things. Something like question 5 is highly likely as one of the questions, just because since it's an integral function, it's going to involve fundamental theorem of calculus, but it'll also involve like function analysis as well, and it'll involve integrals and understanding the area under the curve, doing that. It'll involve like function analysis on max, min, increasing, decreasing points of inflection. They can ask all sorts of different things with that. So a question like 5 is highly likely, as well as a question like 3, because then they can ask about a particular solution of the differential equation. They could also ask about implicit differentiation to find the second derivative. Lots of different things they can ask with both of those, which is why I think those are likely types of questions. Any other questions you want me to go over? And 5B. Okay, 5B. Okay. Well, on 5, we have this graph of f, and we are told that we're dealing from -5 to 5, and they gave us this function g, where g is a accumulation function or area function or integral function. integral from 1 to x of f of t dt. Part A just asks you to figure out what g of 5 is and g of negative 5 is. So you'd just be plugging that in to find the area under the curve, since g is just that area. Part B wants g of 4, which would just be the area under the curve, and g prime of 4, then g double prime of 4. Well, let's make sure we understand what g prime of x is and g double prime of x is first. And I feel like that's probably what Anna Grace is really asking. So, well, if this is Rg, and we want g prime of x, and we take the derivative of an integral function, derivative of an area function, that just becomes f of x, based on the second part of the fundamental theorem of calculus. That whatever is up here as our upper limit goes down there. And then if this is more than just an x, you'd have to multiply by its derivative, as in chain rule. So then also g double prime of x is f prime of x. So then because of this, that means this graph of f is a graph of g prime of x. And if you were to have a question like this, it would be worth a point just to write that down, just to write down that g prime of x is f of x. That'd be a point, just for your knowledge of how that works with the fundamental theorem of calculus. So then let's do B. So g of 4. I'm gonna write it up here. That keeps getting in the way. That would mean integral from 1 to 4 of f. So integral from 1 to 4. That's the integral area of that triangle. We drop that straight down. That's 1 times 2 divided by 2, which is just an area of 1, plus 2 times 2 divided by 2, which would then just be an area of 2. So 3. Okay, then g prime of 4. Well, g prime of 4 is f of 4, and f of 4 is 0. And then g double prime of 4. G double prime of 4 is f prime of 4, meaning the slope of our function when x is 4. The slope of the function when x is 4. So what is the slope of this line here? Well, right here at 3, it was at 1. So it goes over 1, down 1, over 1, down 1. So the slope is a negative 1. Okay. So this is another reason why I definitely think a question like this is definitely possible, because once they ask something like this, what g of 4 is, g prime of 4, g double prime of 4, well, then they could also ask whether that's a max, min, or neither. Do they ask that at some point? They probably do. Well, yeah, C asks where all the horizontal tangents, say whether they're maxes or mins, and well, this is then one of them, because they're asking about horizontal tangents of g, so that'd be when g's derivative is 0, and so 4 is one of those times when g's derivative is 0. So so then 4 would be one of the answers for part C. And then since the second derivative is negative, that means it's concave down. So x equals 4 is where we have a relative max. G has relative max. So they can ask lots of questions with these. You know, we get into that function analysis stuff. Okay. Any other questions? 4, 1, and negative 3. And not negative 5. Hmm. 4, 1, negative 3. You're asking why is negative 5 not 1? Okay, determine whether the reason negative 5 is not 1. Go back and do this so I can write again. The reason negative 5 is not a relative max. Yes, it is at 0 there. The function is at 0, and again, f is g prime. Well, what they asked in C is to determine whether we have a relative min, max, or neither at those values. Well, based on both the first and second, based on the first derivative test and the second derivative test, any test to find a relative min or max. First derivative test says we need to compare the derivative on either side. If the derivative, if f prime changes from positive to negative or negative to positive, then it would be a relative max or min. But we don't know what f prime, g prime, we don't know what g prime is doing to the left of x equals negative 5. This is all they gave us, but hypothetically, it could go back up that way. It could do all sorts of things. So, and the reason it's not a horizontal tangent is since, I feel like it should be listed under the horizontal tangent, but it's definitely not a max or min because we have no idea whether it's going from negative to positive or positive or negative. What that erase? I don't know. Does that answer your question? The reason they didn't list it is because it's the endpoint. It could be an absolute max or min if you actually figured out what G was there. What F is there, but not G. Yeah, what G is at negative 5. But it's not a relative max or min for sure because it's at the endpoint. Yeah. Okay. Madison, you asked about 5L. Okay, we'll go hit 5L. Was that 5? Oh, this is 5. 5L. Okay, give me a second. It'll be hard to go back and forth. Or I could just. I'm going to copy the picture so I can do it in here. L. No, L is actually one that I really think that it's highly likely, really, all of J through M are definitely likely questions to be able to check chain rule, quotient rule. L is going to use L'Hopital's rule, most likely. And M can test both normal derivative rules as well as fundamental thermocalculus. Okay, let's. Copy. Okay, so L, that is what you want to find here. Limit as x approaches 1 of 2g of 2x minus 2 over x squared minus 7x plus 6. Okay, and I'm just currently assuming it's going to be L'Hopital's rule. I'm going to take a limit at the top and a limit at the bottom separately. Limit as x approaches 1 of 2g of 2x minus 2. Okay, well, if we plug stuff into that, that would be 2g of 2 minus 2, and g of 2 g's right here. That was a g of 2 would mean integral from 1 to 2 of f. Integral from 1 to 2 of f is that triangle with area 1. So yes, that is 0 because g of 2 is 1. Okay, then the limit of the bottom limit as x approaches 1 of x squared minus 7x plus 6. If you plug 1 into that, that'd be 1 minus 7 plus 6, which is 0. Okay, so we can use L'Hopital's rule. And so then we have limit as x approaches 1 of, I'm just going to rewrite it right now to g of 2x plus 2 over x squared minus 7x plus 6. And by L'Hopital's rule, it will take the limit notation, but the limit of the function now equals the limit of its derivative of the top and the derivative of the bottom. So derivative of the top, okay, that will be 2g prime of 2x times the derivative of the inside. Gotta use chain rule here. So we'll have 4g prime of 2x. And derivative of minus 2 is just 0, so that went away. And then derivative of the bottom will be 2x minus 7. Okay, well now it should work out. If we now take the limit x approaches 1, plug 1 in, that's then 4g prime of 2 over 2 times 1 minus 7, which is just 2 minus 7, which is a negative 5. Okay, well, we need to figure out what g prime of 2 is. Well, g prime of x, we've already stated multiple times, is just f of x. F is g prime. Okay, so we want g prime of 2, so that's just going to be whatever f of 2 is. F of 2 is 2. So this is 4 times 2 over negative 5, or negative 8. There we go. That's a very likely question, or something like that, where it involves. This problem involved L'Hopital's rule. It involved normal, just power rule derivative to take it over to the bottom. It involved chain rule. It involved fundamental theorem of calculus. It involved using the integral function. So something like this is highly likely because one problem used so many different concepts. Yeah, well, it's now 12. The key is posted, so that should help a lot. As I said yesterday, as I said at the beginning, please practice the demo ahead of time. If you have any questions about how to upload stuff, how these systems going to work, feel free to ask. Please watch the YouTube videos that are that site that I keep linking to. They are very helpful. And we'll have another one of these on Friday to answer any other questions you have about these FRQs or just how the system will work. And if enough of you join Friday, we'll do a Kahoot. Well, goodbye, everyone. Have a great day.